Okay, let's start with a little word association game just to kind of get our heads in the right space. If I say the word acid, what's the very first thing that pops into your mind?
Oh, that's easy. Danger. For sure.
Right.
Yeah, a bubbling green beaker, maybe? Something from a sci-fi movie where it just burns through the floor of the spaceship.
Exactly. It's an immediate do not touch signal. Now, okay, what if I say disinfectant? What sensation comes to mind?
The sting. 100% the sting, that sharp bite when you put rubbing alcohol on a scrape.
Yes. And I feel like we've all been sort of collectively trained to believe that the sting is the whole point.
Oh, totally.
Like if it hurts, it must be working. That whole no pain, no gain thing, but for, first aid.
It is the classic mentality. We equate that burn with being clean. If it's fizzing and stinging up a storm, we think, good, it's doing its job.
But if you poured something on a cut and it just felt like water, you'd probably think it was useless.
You'd assume it was doing absolutely nothing.
Well, today we are going to completely flip that script. We're doing a deep dive into a compound called hypochlorous acid, or HOCl. And here's the paradox that honestly confused me when I first started reading about this. It is an acid, but the research says it's gentle enough for a baby's skin. It's a powerful disinfectant, we're talking hospital grade, but it doesn't sting.
And here's where it gets really fascinating and why I'm so excited about this one. This isn't some new synthetic chemical cooked up in a lab to try and mimic nature. It's actually created inside the human body.
See, that is the part that just blew my mind when I was going through this source material. We're all just walking around with a little disinfectant factory inside us.
We are. It's arguably nature's oldest and probably most refined germ killer.
So just to set the stage for everyone listening, we're looking at a pretty serious stack of research today. We did a deep dive into resources from Era Organics, who break this down really well, but we're also pulling in specific scientific studies from 2007 all the way up to a dermatology review from 2025.
Which is great because it gives us that historical context, showing this isn't some fad, but also the cutting edge uses.
Right. And the mission for this deep dive is pretty clear. We want to understand how this stuff works, why it's challenging that whole if it burns, it's clean idea, and how it can handle everything from a scraped knee to really complex problems like diabetic ulcers.
It's a huge range of applications.
So let's start at square one. What exactly is hypochlorous acid? Because I got to say, even after reading about it, hypochlorous still sounds like something I should be wearing safety goggles to handle.
It does sound intense, I'll give you that. But simply put, HOCl is a naturally occurring antimicrobial compound. It's not a drug in the traditional sense. It's actually a key part of your own immune system.
Okay, so where is it coming from? Like where in the body is this little factory?
It's formed inside your white blood cells, the neutrophils, to be specific. So when your body detects an intruder bacteria, a virus, whatever, your white blood cells rush to the scene. And once they get there, they start producing this acid as a weapon. It's the body's own way of targeting and neutralizing threats.
That's just incredible. So for like millions of years before we had first aid kits, this was our frontline defense.
Precisely. And the way it works, the mechanism of action, is actually pretty elegant. A traditional antibiotic might work by poisoning bacteria, which can take time. HOCl is way more direct. It works by physically disrupting the membranes of the microorganisms.
So it's not poisoning them, it's more like it's dismantling them.
Exactly. It just breaks down their cell walls and oxidizes the proteins. It basically just pops the balloon.
Okay, but here's the million-dollar question. This is the part where the word acid gets scary for me. If it destroys cell membranes, and I'm made of cells, why doesn't it destroy my cells? Why doesn't it damage healthy tissue?
That's the beauty of our own biology. It really comes down to selectivity. Because it's produced by our bodies, our own cells have defenses against it. Human cells have these antioxidant mechanisms that can handle it. Bacteria and viruses, they don't have that shield.
So it's like a smart bomb. It's programmed to hit the bad guys, the pathogens, but it spares the civilians, which are our own cells.
That is a perfect analogy. It takes down the microbial load without creating this scorched earth effect that you see with a lot of harsher chemicals.
Scorched earth is a great way to put it. So let's talk about those. The scorched earth chemicals we all have in our medicine cabinets right now. Hydrogen peroxide, iodine, rubbing alcohol.
The old school staples.
Yeah.
The stuff that smells like a doctor's office.
Right. And the source material draws a pretty strong line here. It says that while things like iodine definitely kill bacteria, they come with a big hidden cost.
They do. They're often what we call cytotoxic.
Let's unpack that. Cytotoxic.
Cyto means cell, and toxic is, well, toxic. So it means these things are poisonous to cells. The problem is they aren't just poisonous to bacterial cells, they're poisonous to your cells, too. Specifically, they damage things called fibroblasts and keratinocytes.
I remember reading about those. The fibroblasts are kind of like the body's construction crew, right?
Exactly. They're the cells that your body sends in to knit everything back together. So imagine this. You get a cut, your body sends in the construction crew, then you pour on some hydrogen peroxide and watch it bubble up.
Which is so satisfying to watch, I have to admit.
It is, visually. But that bubbling, that's a reaction that is basically nuking the construction crew. You're not just killing germs, you're wiping out the very cells that are trying to heal you.
So you're taking one step forward, killing bacteria, but then maybe 1 or 2 steps back by destroying your own repair team.
Sometimes more than 2 steps back, yeah. And that damage is usually what you feel as pain or stinging. That sting isn't healing, it's irritation. It's your nerves screaming that healthy tissue is being damaged. It can actually delay the whole process.
That's such a huge mindset shift. We think the bubble means clean, but really the bubble just means, ouch, stop it.
Exactly.
And that brings us back to the HOCl advantage. The sources all highlight its low toxicity.
Right. It cleans the wound without stripping away that new granulation tissue, that fragile new pink skin that's forming. HOCl protects it.
And the pain.
Much, much lower. For most people, it's non-existent. It doesn't usually sting because, unlike alcohol, which just dehydrates the cells, HOCl doesn't do that. Plus, the formulas are pH balanced. They kind of mirror the body's own chemistry.
So it's working with the body instead of just carpet bombing the area.
It's creating a stable environment for repair to happen.
Okay, this is all great for, a paper cut or my kid's scraped knee, but the research you brought in covers some much heavier lifting. We're talking chronic wounds.
Right, and this is where the science gets really compelling for me. Because treating a fresh cut on a healthy person is one thing, but treating a chronic wound like a diabetic ulcer or a pressure sore, that's a whole different ballgame. One of the biggest problems is something called a biofilm.
Biofilm, that sounds like, I don't know, something grows on my shower curtain if I don't clean it.
It's not that far off, actually. Bacteria are smart. They don't just float around by themselves. They cluster together, and they secrete this slime-like shield that protects them from your immune system and from antibiotics.
So they build a little bunker.
They build a slime bunker, yeah. And most traditional antibiotics just bounce right off of it. They can't get through. But the source material notes that HOCl is really, really good at disrupting those biofilms.
It breaks down the bunker walls.
It breaks them down. Because the molecule is so small and has a neutral charge, it can actually penetrate that slime and get to the bacteria hiding inside.
You pulled a specific study on this, didn't you? About diabetic ulcers.
I did, yeah, from 2017. It was about using hypochlorous acid on infected diabetic foot ulcers.
And those are notoriously hard to heal, right? They can stick around for months, even years.
Incredibly difficult. You have poor circulation, reduced sensation. It's just a perfect storm for infection. What the researchers found was that HOCl gave them really effective antimicrobial action without being cytotoxic. It didn't damage the fragile tissue around the ulcer.
So it was strong enough to kill the infection, but gentle enough not to make the wound worse.
Exactly. And they found it was safe for long-term use, which is critical. You can't put harsh chemicals on a wound every single day for 6 months. You destroy the skin. HOCl is gentle enough to be a daily treatment.
And it's not just bacteria.
Yeah.
I saw a note here about fungus, which honestly is not something I love thinking about.
No, but it's a crucial point. Antibiotics kill bacteria, but they don't touch fungus. In fact, sometimes using antibiotics can actually clear the way for a fungal infection to take hold. But HOCl is broad spectrum.
Which brings us to that 2007 research.
Right, Wang's research. It found that stabilized HOCl also inhibits yeasts and molds. This is so important for wounds in moist areas where circulation is poor. A warm, wet wound is a playground for fungus. HOCl shuts that down.
It really is like a Swiss Army knife for wound care.
It is. Bacteria, viruses, fungi, biofilms, it goes after all of them.
Okay, so we know it cleans well, we know it doesn't burn. But let's talk about the vanity metrics, speed and aesthetics. Because if I get a big cut, I want it gone yesterday, and I don't want a huge scar.
Well, you're in luck. The research suggests HOCl helps with both of those things.
Let's talk speed first. How does it make things heal faster?
It goes back to our construction crew, the fibroblasts. Because HOCl isn't killing them off like peroxide does, it actually promotes their activity. It encourages something called reepithelialization, which is just a fancy way of saying skin regrowth.
You found a 2014 study on this.
I did, yeah. It looked at septic traumatic wounds, so these are really nasty infected wounds. Not pretty.
And the result?
Faster wound closure. They saw a big reduction in the bacterial load. Basically, by clearing out the infection so efficiently, it let the body switch from fighting a war to rebuilding the city a lot sooner.
That makes perfect sense. If the body isn't fighting, it can focus on building.
Exactly. And that leads right into the scarring.
Which is huge. I feel like we all just assume scarring is genetic, oh, I'm just a bad healer. But there's a process there.
There is. A lot of scarring is a result of inflammation. When a wound is angry and red and swollen for a long time, the body kind of panics. It just throws down collagen in a messy, disorganized way to plug the hole.
Panic building, like putting up a barricade instead of building a proper brick wall.
That's a great way to put it. And that messy collagen leads to those raised red hypertrophic scars.
So being calm leads to a smoother result.
In a way, yes. There's some very recent research cited here from 2025 on hypochlorous acid in dermatology.
2025, so this is brand new.
Super fresh. And the key finding was that HOCl calms that inflammatory response. By keeping the wound clean and reducing that angry redness, it allows the collagen to be laid down in a much more effective, organized way.
Meaning a flatter, smoother scar.
Exactly. It creates the conditions for a good aesthetic heal, not just a functional patch job.
So what does this all mean for someone listening? We've gone through the science, the scary ulcers, the scarring, but how do we actually use this? Say I scraped my knee hiking this weekend. What's the protocol?
The practical side is surprisingly simple, and I really want people to hear this, there is one critical step that almost everyone misses, and it can ruin the whole thing.
Okay, walk us through it. First, what are we looking for in the store?
The source lists a few options. Sprays are the most common, usually in a very low concentration, like 0.01% to most 0.1%. Then you have hydrogels, which are thicker and good for keeping a wound moist. And there are also wipes for on the go.
Okay, so I've got my spray, step one.
Step one is still the basics. Clean the wound. Use mild soap and water or saline to get any dirt or debris out. HOCl is a disinfectant, not a broom. You have to get the physical junk out first.
Got it. Wound is clean. Step two.
Apply the HOCl. And be liberal with it. Don't just do one little spritz. Really soak the area.
And here it is. Step three, the curveball.
This is the critical step. You have to allow it to air dry naturally.
Don't wipe it off.
Do not wipe it off right away. The source says give it about 3 minutes.
3 minutes. That feels like an eternity when you're just standing there. Why is that so important?
Because it needs contact time. The antimicrobial action isn't like a lightning strike. It needs those couple of minutes to physically break down the cell walls of the bacteria and get to work on any biofilm that might be forming.
That's such a good tip. I bet 90% of people spray it and then immediately dab it dry with a tissue.
I would guess so. And if you do that, you're basically pulling the worker off the job before it's done. So spray it on, let it dry, maybe check your phone for a minute.
Then what? Step four.
Repeat. Usually 1 to 2 times a day is standard for a simple wound.
And finally, just monitor it.
Always. Keep an eye on it. But, and this brings us to safety, HOCl is generally very, very safe.
The text mentioned some possible side effects, but they seemed pretty minor.
Very mild. You might get a brief stinging, maybe a little redness or a warming sensation right after you put it on. But the source makes it clear that these fade really quickly. It's not that lingering burn you get from alcohol.
And for home use, is this safe for my kids?
Yes, absolutely. Specifically, those low concentration formulas. They're designed for consumer use. It's safe for kids. And it's actually excellent for elderly skin, which can be super fragile and thin.
It's interesting to think about the whole shift in mindset here. We're moving from a war metaphor, attacking a wound with harsh chemicals, to more of a support metaphor.
That's the perfect way to frame it. You're supporting the body with a compound it already knows how to use. You're basically saying to your immune system, here, have some more of the ammo you're already making.
It's balancing killing the germs with preserving the skin that's trying so hard to grow back.
And that balance is what makes it so useful across such a wide spectrum. From a simple kitchen cut to a really complex ulcer, the biological principle is the same.
It really feels like this is one of those things that should just be in every modern first aid kit.
Absolutely. Especially now that the stability issue has been solved. It used to be you couldn't bottle this stuff for long, but now it's stable and ready to go when you need it.
This whole conversation leaves me with this one thought. We tend to look for medical miracles in like exotic plants or in some high-tech lab. But here we have this incredible disinfectant that our own bodies have been quietly making for millions of years.
It really just highlights the elegance of our own biology, doesn't it? Sometimes the best solution has been inside us the whole time.
It does.
Hmm.
And I want to leave everyone listening with this idea to think about. If our own immune cells have been making the perfect disinfectant this whole time, what other medical miracles are just hiding inside our own biology, waiting for us to figure out how to stabilize and bottle them?
That is a fascinating question. The answers are probably already circulating in our veins.
Something to mull over. Thanks for joining us on this deep dive into hypochlorous acid. Stay curious, everyone.